Hello, everyone. It is my absolute pleasure and honor to welcome our speakers, Pedro, Murali, Diana, Mohamed, Nathan, and Kelvin, to our live Q&A session today. Before we get started, I'd like to remind all our viewers that you could post your questions to the AtScale conference link. And with that, let's get started. And thanks to everyone who've already posted your questions as well. I'd like to start with you, Pedro, on the composable data management systems. The first question here is the community behind Velox has very rapidly grown since it was open source 2 years ago. What do you attribute to that?
Yeah, no, thanks for the question. Happy to be here as well. Yeah, I think on the open source part, because Velox was kind of such a large effort and such a large endeavor, one of the first things we did when we started the project was kind of looking at the community and talking to other companies and trying to understand like what other companies have similar problems and would be kind of willing to partner with us. So kind of in the very beginnings of the projects, like we chat with most other companies, and we started seeing that it was a very common issue, or like something that many other companies and organizations outside of Meta would like to invest on. So I think we started talking to Intel early on, to Voltron Data, to Ahana, and they all kind of had efforts around kind of trying to make compute engines more efficient. So we ended up creating a collaboration between those companies and saying like, well, let's not do all those kind of invest on those projects in a decentralized way, and like let's rather kind of join forces and start working on this. But this is kind of how we started, and then I think the more companies joining, of course, the faster the project started making progress and like adding features and becoming a lot more mature, and then like other companies started to join. But I think it was just this idea that was something very it's a problem that many companies had and many companies were willing to invest on. So that just kind of resulted in a very kind of quickly open source growth, which we're very happy about.
Awesome. That's a wonderful story of a flywheel effect with open source partnerships. Thank you. The next question we have here is for Murali. When we think of Razorpay and the fast growth that it's had, a lot of companies focus on product market fit. So from your view, what are some of the things that you would recommend taking care of while we're in that phase so that when you scale, things become easier to handle?
Thank you, Manju. I think the first thing is about the architecture to be done better at the design phase itself. It's when you are chasing AMF, we call it the 0 to 1 journey. You need to ideate faster and eliminate bad ideas sooner, but then quickly it turns into 1 to 10 and 10 to 100 type of opportunity. So at that time, rewriting your service is quite difficult to do. So I would always start with proper design and make sure that the operating principles are very clear. For example, in my organization, I focus on engineers to know that security is the top priority. Make sure the design takes care of security. Make sure compliance is clear from the starting, because company may not exist if compliance is not taken care of. Reliability, availability, performance. Think through all of that. But only when the basics is covered, innovation happens. So that's the learning, and we have been trying to do that at Razorpay.
So resilience and security first, infrastructure. That's awesome. Right. Thanks for sharing that. The next question we have here is for Diana and Mohamed. How do you ensure, so this is about your talk on how Gen AI can be leveraged for incident response. How do you ensure responders are not misled or distracted?
Yeah, we share a little bit about this in our talk, and we really want to make sure that we're very transparent about what are the data that the AI are leveraging to give the response. And then we're also trying out new things, such as having AI share the confidence level that it has, so that the user is also more aware about kind of around using the information that AI is passing back. We are asking everyone to do the verifications and making sure and not just taking the answers and the response from the AI blindly. Mohamed, anything that you want to add to this?
Yeah, thank you for sharing. I think adding the confidence level for the responders is super helpful. I agree. The next one we have here is on Arctic, and the journey how you went from 0 to 1 in 5 to 6 months is pretty fascinating. We'd love to hear from you in terms of what are some of your future plans in the data processing for Arctic.
Oh yeah, I can speak to that. So one thing that we recently just experimenting is so we recently in Snowflake, right? We released something called LM function in GA. So what it really helped us is that in the talk, right, we talk briefly about how you can use the streamlet to kind of label the data bad and good. But right now, with the function, you can actually prompt any model we have there and then ask to do some rating for you and in much more scalable way and cross track with the human label that you have, right? Then you can do it much more efficiently on any of the data labeling annotations to help to increase the quality of your pre-training data. The other thing that we are exploring how to generate synthetic data that will also help with getting a better models. Yeah.
Got it. Synthetic data and human intervention.
Yeah.
That's pretty
awesome. Yeah, doing data annotation with the LM functions, prompting the other models to help us to label or annotate the data. Yeah.
Very cool. Thank you. We'll go back to Pedro. There's a few live questions coming in. Pedro, what do you mean that Velox is engine agnostic while it is an execution engine by itself?
Yeah, I think what we mean by execution engine is more like it's a library that we provide that's able to execute operations in a host, right? So it's not like by execution engine we don't mean the actual entire compute engine. It's just the library that knows how to execute those things. And I think the idea is that we can integrate the same library into multiple compute engines. And I think this idea of being engine agnostic means that you can actually take Velox and integrate into different systems with different semantics, with kind of different characteristics, because the library is fully extensible. So you can actually take Velox, integrate into Presto, and then use kind of the entire Presto ecosystem, the Presto service, and then you kind of configure and add all the extensions needed for Velox to follow the exact Presto semantic, but you can do the same thing in Spark, you can do the same thing in other different systems, right? So the kind of the right mental model is just assuming that this is a library that you integrate with other services.
That's awesome. Yeah, thank you. The next question we have live here is for Murali, right? So you talked about Razorpay being the end-to-end platform for merchants. From a privacy perspective, what is your view on providing merchants with information about customer behavior, such as the chance for return to origin?
Thank you. It's a very good question. What we provide to the end consumer is a faster checkout option called as Magic Checkout. Razorpay as a payment gateway is providing this payment gateway functionality to multiple merchants. And you can imagine that when a consumer is buying from a website, they may not be comfortable sharing their contact information and payment information to a random merchant website. So this Magic Checkout option with consent allows consumers to let Razorpay pre-fill the addresses, contact information, payment information, and so forth. Along with that consent, they also agree to let merchants provide better service to them, including remembering the payment options to give a better experience. So essentially what we are providing to the merchants is an option to configure which payment method shows up first. So instead of payment on delivery option, merchants might choose to show a credit card or debit card on the top. So that's how we handle with privacy. It's with consent.
Got it. Yeah, I think the consent is an important factor. Thank you. The next question we have here is for Diana and Mohamed. Do you, with all the talk about AGI, right? Do you expect at some point investigations will be completely automated?
Yeah, this is a great question, actually. I while we are far off from that point, what we are trying to do is see where we can start building small building blocks to get us to that North Star. It might be far-fetched that all of this will be completely automated through AI, for example, but at least maybe it would cover the biggest operational burdens for engineers, where engineers can verify the work and either approve, decline, suggestions, and so on. So maybe we are far off, but we are working toward like a North Star that's close to assisting engineers so that they don't have that much workload.
Got it. Yeah, I think it's maybe hard to put a time frame for solving this problem, but definitely exciting. The next question is for Nathan and Kelvin on Arctic. Does this generalize to multimodal?
Yeah, I think so. So there are two components of what we talked about. There's the data storage part of it, and then there's all of the data annotation, slicing and dicing, making sure that your policies are enforced and all of that. For any data source, no matter what it is, no matter how big the blob, there's always going to be metadata associated with it, license, whatever category it belongs to, for example, science or humanities or whatever. And so all of that can certainly be stored in the database and processed the way we described. There may be stuff like hypothetically, if we went big and outside to videos or something like that, where those blobs are a little larger than what you might normally want to put in even an analytical database like Snowflake. That might be stored outside, but the core idea is the same. The idea being the metadata and the attributes are the things that you want to filter on and process. That all can be stored in this manner.
Yep, that would help from a quality perspective.
Exactly.
Very cool. The next question I have here is on the Velox presentation, right? How is the experience and cost of migrating existing data systems over to Velox?
Yeah, I think that depends a lot on the engine you're integrating Velox to and kind of how kind of broad the integration surface is. So we see, I think maybe naturally, like when you're developing new engines and you kind of want to do that using Velox, it's a lot easier, right? Now kind of integrating Velox and kind of doing a surgery into existing engines, that's something that gets a little more complicated, especially if it's something that already runs in production and something that already has a very large footprint. Like those the integration themselves are very complex projects that might take quite some investment. So I think usually the mental model is what value does that value, and does the value the integration add actually pays the investment, right? But I think maybe the answer is kind of depends. Of course, integrating Velox into kind of very mature SQL analytic engines, like I think I mentioned in the presentation, like Preston, Spark, like those are probably the most complicated integrations just because the surface is pretty broad. Like it uses all the entire library, like all the SQL operators we provide. There's also a lot of discussion that it needs to provide the exact same, it needs to follow the exact same dialect and provide the same semantics to users. Otherwise, it might break backwards compatibility. So even when things are stable and hardened and well tested, we need to make sure that it kind of provides every single kind of semantic issues and kind of a bug by bug implementation of those things, right? While in some systems, like sometimes you're just reusing the same memory layout or just the serialization function, like this is a kind of a lower level integration. It's a lot easier. It kind of depends on, I guess, like the maturity of your engine, and depends on how many things and what's kind of the complexity of this integration.
Yeah, I think that's very fair. And once you get to a composable place, then you're able to move faster. But getting to that state, especially when you're not in that state, is going to take time.
Yeah, and we already have a few examples of new engines we developed inside Meta that kind of came after Velox. It was already mature, and I think that's what we're trying to get, and what we mean by this engineering efficiency. Like in those cases, we're able to move much faster. Now, kind of retrofitting this into existing engines, it's a much higher bar, but it still makes sense in some cases.
The next question we have is for Murali. What are some recent product innovations at Razorpay that you are most excited about? A sneak peek.
In terms of technology use, in the last 1.5 years, the Gen AI has come to a place where we have figured out how to provide good functionality to customers and for engineer productivity internally as well. For example, the DevOps organization is able to debug live issues in Kubernetes by using LLMs. So essentially, we have put our SOPs as part of prompt files, and we are able to debug things much faster. And we have made it self-service for our engineering organization, which is pretty cool. We also are doing Docs AI, for example. Developers that are looking forward to integrate with RazoRPay have to go through API documentation, figure out how to integrate and whatnot. That is a long process in general. We are able to cut that down and also build a one-click migration from our competitors. We built that with the LLM. So given the API specification, we're able to convert the code. These are quite exciting. So I'm looking forward to doing a lot more there in terms of providing functionality to our customers.
That's awesome. Thanks for sharing those. I think this is also very close to the incident management work that we've been doing at Meta. So the next question is on this topic, right? How are you thinking about the balance between human and automation when it comes to incidents?
Yeah, so I think we, in both short-term and midterm, we really see that we do need help from both, but also trying to figure out how do we go from right now where it's very manual to maybe perhaps a stage where AI is doing a lot of assistance with human making the decisions. And then ultimately, can we get to a place where the role might be switched a little bit, where AI might be doing some of the planning, especially learning from experts, learning from past experience, but with human kind of in the loop and make sure that AI is doing the right thing and making sure that there's some traceability in the way to continue guide the AI in the right place, but continuously changing the percentage and balance between manual to AI to kind of in between.
Yeah, makes sense, right? I mean, I think it's we want to make sure that what we do well, like we are very clear about it, and where we're not quite there, to highlight that part. Cool. The next question here is for Arctic, Nathan and Kelvin. At this scale of data, right, the pre-processing becomes super important, right? So what are some of the pre-processing steps, pre or post-processing steps, do we need to do outside of Snowflake?
So I'll take that. Snowflake is really great for what we're doing is data orchestration and filtering. But beyond this, there's this black box, which is training the LLM. And for that, you have to take your textual data as it is now, eventually multimodal. You need to do this step, which is tokenizing, which is replace some set of character sequences with a unique ID. And once you have that, there's this very important step, which is to come up with a data composition, which is how much of web data, how much of code data, how much of Python versus SQL do you put in the model at this phase of training? And then after that, how do you iterate? And Kelvin showed a little bit of that in his talk, where we train these smaller models, these ablation models, all out of band, all out of Snowflake, but we evaluate them, and then the output of those models and the output of the evaluation goes back in. And so that allows us to complete the loop. And so that's the theme we've been hearing from a lot of people, which is the real value that we're all trying to drive for is the ability to iterate quickly. And so that's the thing that was the motivation behind what we did around Snowflake. But the idea is the only way to get to a good LLM as quickly as possible is to shorten that iteration loop as much as possible, especially when training on GPUs takes weeks at a time. And so right now, the large part of the work is figuring out the right data to add at the right time. And for that, we're doing a lot of experiments out of band.
Got it. Yeah, that iteration time means everything in training. That makes a lot of sense. Cool. So we're back to a question on vlogs. So Pedro, after a common execution engine, which is vlogs, and a new storage format, Nimble, what are some of the common components of the composable data stack that Meta is focusing on?
Yeah, that's an interesting question, right? Yeah, I think we've been really focused on execution engine. Like you said, we've been evolving the file format. I think in theory, technically, all those things would make sense to kind of, just unify and provide common libraries. I think the question is usually how much value would that add, and what is the cost of doing those things, right? So I think at the end of the day is based on ROI, like what the return would what is the return of the investment over those things. So that's why we started on the execution engine, just because there's a lot of CPU power, there's a lot of resources that go into those things. So if we can make this cheaper, like it actually provides a good return over the investment. I think usually when we look at other parts of the stack, that's sort of the discussion, like, okay, this makes sense. And I think technically not many people disagree that this would be interesting to build, but the question is more like how do we prioritize those things? I think answering the question, we had some internal efforts on unifying, or at least kind of starting to unify the language part. I think, of course, like if you had a single SQL dialect that you can provide to users across engines, this would be ideal. And I don't think anyone would disagree that this is, kind of the best case scenario. I think the question is usually kind of what's the cost and how much effort goes into that. I think part of that is, well, we can only do that if you actually have the same engines running the same code bases so that they can provide the same semantic. But we had some internal efforts on, at least like for the engines that already provide where we want to follow the exact same SQL dialect for users, like at least providing libraries that can provide kind of parsing capabilities or kind of providing a more unified IR. So we have some of that internally, but it's still, I think it's not very clear like what's the value. So I think that would probably be the next project in terms of different parts of the stack. But I think maybe the underlying message is just like we need to be careful about what are the things that are worth doing and how much return that would provide.
So lots of work going on, fairly early stages. So okay. The next question we have is for Murali, right? So how do you propose handling operations at scale, right? So there's the process component, there's the tooling component, there's the people component. Like what would you say is the biggest challenge? And what are your thoughts on resolving them?
I think you have listed all three of them correctly. So it goes in cycles, though. I would say the most overlooked ones are usually done in the early stages. For example, is your architecture tightly coupled? Because initially it might allow you to ship faster, but then after a while it becomes harder to ship features, and then it will cause customer experience problems with regressions and so forth. So I would say start early on with better design so that you can have velocity later. Do conduct periodic operational reviews so that the engineers are exposed to the problem so they can work on resolving them, or at least have more time before something becomes big, along with the things that you mentioned that allows you to scale.
Thanks for sharing that. Diana and Mohamed, from a scaling Meta's infra with Gen AI perspective, like how do you see incident management changing with AI?
So I think multiple factors will happen. Like from one perspective, right now our focus on like how can we improve response through LLMs and AI, but we are also trying to discover and explore other areas. Like similar to what Diana mentioned during the presentation, like how do we prevent these from happening in the first place? Like how do we integrate these as a part of like the developer ecosystem so that we are not late into the process? So I think over time we will see this being integrated into many parts of the developer workflow. And also we expect that as time passes, we will be able to reduce the workload on the responders and hopefully be able to provide more accurate back our data and maybe even verify these assumptions or these decisions before sharing them with the end responders. Again, it's a long journey, but like as Diana mentioned, we are 1% done.
That is absolutely true, the 1%. Cool. I think we have maybe time for one last question on Arctic. What is the scale of data that you have used this within Snowflake?
Yeah, thanks. I will take that. So yeah, so basically, like we for Arctic, we use roughly 3.5 trillion token to pre-train our models, right? And then like I would say roughly about like half is like processed through Snowflake, right? And then like if you think about that, right, that's like roughly like each of the token usually is 2 bytes, so it's like we are talking about terabyte of like maybe 2 to 4 terabyte of data being processed through Snowflake and then kind of like pre-train our models. So yeah.
Awesome. So it's like 50-50. Okay, got
Yeah.
it. I believe that is all the time we have. We're going into a break right now. Again, thanks everyone for joining us today for Q&A. We appreciate your time. Thank you.